In our previous sessions, we created all of these parts for our assembly radial engine. We also assigned the materials and included them into our custom properties which can be accessed by our bill of material. Now without further ado, let's start creating the assembly. As you can see in our assembly, we have lots of repeating parts. And into that repetition, we can notice that there are set of parts which are repeating multiple times, like this articulated rod and the parts attached to them can be considered as a subassembly. So before starting and creating the assembly or final assembly right away, we will create a subassembly of this articulated rod. Once that is done, we will start creating a main assembly where we will upload the master rod as our main part and then the subassemblies of this articulated rod. This way it will save lot of time to assemble these individual parts on every repetition. So let's start creating the articulated rod assembly now. I prefer to keep these parts open in the background while creating the assembly so that they are easier for me to access. But it is really not necessary. If your system has a limited amount of memory, that is RAM, then be sure that you don't open all of the parts for your assembly. These are actually very few parts, but if you have like 50 or hundreds or 200 amounts of parts, then it becomes very heavy for your computer system to manage all these files at once. So make sure that you're working on a stable system. In this case, these parts are very less, so I am preferring them to be open in the background while creating the assembly. To start the assembly, we will click on this new command, and from the templates, I will select assembly. If you are on novice mode, you can select assembly. It will select the default template assigned into your Solidworks settings. Click OK. I will just maximize this window now. And as the parts are open in the background, you can see all of the list of the parts available for an assembly. But if you have not opened all of the parts, then you can click on the browse, and from the Windows Explorer you can travel to the assembly folder. You can select one part at a time and load them for your assembly. Suppose if you are not able to see the parts, be sure that the extension chosen over here is correct. Otherwise you won't be able to see the parts for your assembly. Now I am going to select articulated rod as the default part or the first part to be assembled. Click on green check mark so that this articulated rod gets settled on the origin of our assembly file. You can see that there is an F notation before the name of our part. That means this part is fixed. And it's fixed in such a way that the front plane of this part and front plane of this assembly file are matching. Likewise, top plane, right plane. In short, their origin is coincident with each other. In such case, it becomes easier to not to expand this part and access the planes and origin of this part. Instead, we can access these planes to constrain other parts with this articulated rod. Now I am going to assemble rest of the parts with this articulated rod, and we are going to save this called as articulated rod assembly. I will click on insert components. Let's say I want to insert piston. Also I will insert piston pin. Rod bush lower. rod bush upper, piston ring, piston pin plug. It is not necessary you populate all of the parts at once, but this is how I am going to do because it is very small assembly. Now time to constrain these parts. So we'll click on the mate button over here on ribbon. In this selection box, I will select the cylindrical face of this bearing or bushing, and I will select cylindrical face of the master articulated rod over here. Solidworks will assume the constraint and it will try to apply it. It is saying that a concentric constraint is being applied. This is completely fine with me. I will click on green check mark to continue. I will expand this assembly one feature tree manager. Also after that I will expand rod bush lower. Into that I am going to expand. Into that I am going to select the right plane. In my case it is right plane, in your case it can be some another plane. Be sure that the plane is lying at the middle of this cylinder. See, this way. And then I will expand articulated rod and select top plane, or else without doing that you can right away select the top plane of your assembly. It's one and the same in our case. SolidWorks will assume the constraint to be coincident in standard mates. If you want some other constraint you can change it, but right now it has assumed the appropriate constraint. So I will click on the green check mark to continue. For my requirement, these are enough constraints to hold the bushing at that point. Now I am going to add other bushing at other end in similar fashion. Once assembling the bushings are done, I will add constraints between piston and this bushing. You can just drag and hold the parts and align them as you need. Once you release the cursor or click, you will notice that it has not added the selection. It is a good feature in SolidWorks that you don't need to come out of the mate command to adjust the parts. Now I will expand the tree for piston and select front plane. In your case you can find another plane if you have modeled it in a different way than my tutorial. And then I will select top plane of assembly. Now this piston is free to wobble around this axis. It is not necessary in all of the assemblies that parts will be fixed. They will be having some degree of freedom and we have to make them that way. It is not necessary in my case or in this case to fix this piston or to make this piston fully constrained. That means that we will be able to see minus sign behind the name of the piston and it is completely okay. But suppose if there are parts into your assembly which are supposed to be adhered at their location and all of the degrees of those freedom and all of the degrees of freedom of those parts are supposed to be logged, then After assembling those parts, this minus sign should go away. This is the proof that your part is fully defined and it cannot move from its position or rotate about its position for any direction. After assembling the piston, I will select this pin and assemble it. For piston pin, I am going to follow the same method of assigning the constraints between the planes. Whenever you add constraints in the parts, a separate category over here is available called mates, and you can expand and see how many mates you have applied, and each mate will be showing between which two parts that constraint is been applied. But if the parts are lot and it is difficult to find a specific constraint from this tree, I will suggest that you expand the specific label for that part, and inside that you will find a mates folder created like this, and it will show only those constraints which are applied to that part and the other parts about it. Now it's time to constrain this piston ring. So I'll select this face and I will select this face, and you'll notice that these faces are aligned to each other with a coincident constraint. In my case, the alignment is correct. That means the faces are opposite to each other. But if you will that the faces should be flipped, then you can click on this button called aligned. Right now, anti-aligned is the correct option for our case. I will click on green check mark to finish. Then I will select the cylindrical face of this ring and cylindrical face of this piston over here, and concentric mate has been applied. I will click on finish button to get out of that mate. I will again click on the green check mark to finish this mate command. Now is the time to duplicate these piston rings. We are not going to click on insert components to create the duplicate of these rings. What we are going to do is click and hold on the control button of your keyboard, and from this feature manager tree we are going to click and drag this piston ring out into your graphics area. There is one more method. You can hold control button and you can click and drag the ring in the graphics area to somewhere else, and it will create the copy. You can use any one of these methods which is suitable for your case. Once the copies are created, I will again start the mate command and start creating the assembly for these rings. You can see all of the rings have been placed. From the given example, we have limited amounts of parts, so we don't have any ring information over here, so we are not going to place the ring over here. Also, as you might have noticed that this assembly is not complete, it doesn't have all the parts, the housing information. So just for the practice purpose, I was willing to create this assembly for my students. Now is the time to assemble this piston pin plug. Once this is assembled, I will click on green check mark to finish the mate command. Again click and hold the control button and drag this piston pin plug outwards. You can also click on this cylindrical face, hold control button, click on this cylindrical face, and from the flyout bar you can add the constraints. Due to limitations of my recording software, that flyout bar is not been recorded, so I will continue with the mate command and guide you through that. So we select this cylindrical face and then the piston cylindrical face, the piston pin cylindrical face, and finish with the concentric constraint. Now when I click on this flat face and this flat face, it will add the mate constraint, but this is completely inappropriate. I need to flip this direction, so to do that I will click on this anti-align command. It says that the concentric command is also been reversed. Click OK to continue. We have finished creating the articulated rod assembly. I will save this assembly now. Be sure you are in correct folder. Click save to finish. Let us click on this new button. Click on assembly and say OK. Now we are going to create the main assembly, in which the previous assembly will be loaded as the sub-assembly. Here the master rod will be selected as the primary part, that is the fixed part. So select on the master rod and click on green check mark so that it is placed on the origin of our assembly file. Now again we will go into insert components and select articulated rod assembly and place it over here. We'll select rest of the parts which are supposed to be aligned over here. So we can select link pin, master rod bearing, piston, piston pin, piston pin plug, piston ring, and rod bush upper. We have already put rod bush lower over here, which will be going in with this master rod and articulated rod. So no need to call that part. If there is any part left out, we can load it later on. Now when duplicating the subassembly, it is very important that we don't click, hold control and drag these parts. It will create, as you can see, articulated rod copy, not the whole assembly's copy. So to create the copy of a subassembly, we will click and hold on control button and drag the assembly from the feature manager tree. See, and you can see into your feature manager tree that the whole subassembly is been duplicated and not individual parts. There you go. I will just drag this parts bit away so that there is very less confusion. Let's start with the master rod bearing. Mate command, click on the cylindrical face of both the parts and say OK. We'll expand the master rod bearing, select the top plane, sorry, select the right plane and select the top plane of master rod or your assembly, and you will see that they are properly aligned. You will notice that there is minus sign behind the master rod bearing, but it is okay because this bearing is not completely fixed. It is rotating about its own axis. It is not completely visible or demonstrative in the video, but when you create the assembly, you can cross check that when you drag the part. Now you continue with the mate command. Make sure that they are flipped and anti-aligned. There you go. Now we'll add mates between these parts. Now we have given the information that this flat face, okay, not this one, this is in angle, okay, this is inclined, this is flat and straight face of our part. So this flat face and this flat face have an angle of 70 degrees with each other. Right now coincidence is not possible, so SolidWorks is suggesting to put parallel constraint, but we are going to change it to angular constraint and add the angle of 70 degrees. In reality, there won't be a fixed angle because when these pistons are moving into the cylinders, the angle between these rods will be changing continuously. But in our case, as it is shown that initial position should be this, we can put on this angle, we can add it as a constraint, or you can choose this option use for positioning only and leave these rods free to move for later animation. As in our case, we are not going to create any animation and I want this path to be fixed and not to be dragged anywhere. I am not going to choose this option. So we have the fixed angle between those parts. Let us continue constraining rest of this articulated rod assemblies and our master rod. When you select these faces, don't select the faces which are opposite to each other. Select the faces which are aligned to each other. That means when I am going to put the angle with this face, then we are going to select this side face of the part, not the other side which is facing opposite to this direction. Otherwise it will flip the angle. So it is saying this is parallel, and we are going to say that it should be 70 degrees, but flip the dimension. And you can see this is the 0, and then 70 degree is in this direction, anti-clockwise. You can actually mirror them, but I would prefer that not to mirror and assemble them one by one, because mirror can change the geometry if they are not symmetrical. Now as I have placed this part first, I will just drag it so that there is a space to see this part clearly when assembled. If the direction goes in the opposite side, click on flip dimension, not on flip sides. Anti-align will take your part somewhere else, like over here or maybe over here. Select this face and this face and add the angle. Now we are going to add the link pins. We click on the flip direction. Actually what we could have done is, after placing the first pin, aligning properly, and then we could have created the copy. In a hurry sometimes we do such mistakes. But if there is a solution, no problem at all. It will give us the prompt that the earlier constraint is also reversed. So as displayed in our example, in our book, the assembly is finished. Later on, we will create the exploded view of this assembly, and then we will create bill of material right in the 3D view. Once that is done, we will start creating drawings for all of these parts. Thank you.